All right, that should do it. So welcome everyone to our final session of the day, and thank you broadly for joining the Carbon Positive Reset 1.5 degree C Global Teach-In. We're thrilled you were able to join, and I hope you learned some really valuable insight from the incredible presenters we had joining us today. So this session is Interiors Matter, Material Impacts, Innovation, and MEP. So far in this embodied carbon track, we've talked about high impact structural materials like concrete, steel, and mass timber, as well as naturally carbon sequestering materials. And in this session, we're going to dive into interior materials, the embodied carbon impact of interior materials, tenant improvement cycles, and MEP systems. The learning objectives for the session are shown here. Again, we'll follow up after this event with information on how to get the AIA credits for this session and the event. And in the case we don't get to all of the Q&A, we'll also ask that the speakers answer some of the questions after this event, and then we'll be able to post that on the Carbon Positive website. So with that, we have three incredible women on the session that I'm really excited to introduce. I'll keep their introductions brief so we have time to get to the content and Q&A. So first we'll have Kirsten Ritchie, a consulting project director and principal at Gensler. Kirsten serves as one of Gensler's leading sustainability ambassadors, championing helpful and forward-thinking design solutions, and leading public discussion around innovative and high-performance design and operations. Following Kirsten, we'll hear from Jennifer Chen, an associate interior designer at LMN Architects. Jen's focus is on how design decisions impact human and environmental health. In her firm, Jen leads endeavors in finding ways to lower embodied carbon of interiors over a building's lifespan. And our third speaker is Kelsey Wotila, a designer at EskewDumezRipple. Kelsey is leading a research project at EDR's leading research project focused on reducing the carbon of construction and building operations, including partnering with MEP consultants to accurately quantify the embodied carbon impact of various MEP systems, which she'll be sharing with us today. With that, I'll hand it over to you, Kirsten.
Great. Welcome all. Thank you so much for being willing to stick around the end of this very long day here. Really appreciate that. And with that, wanted to kind of dive right in. Again, we're talking about interiors matter, and I'm going to be really talking kind of a little bit about how we're delivering high performance as well as low carbon interiors. We have to always remember when we're trying to achieve things like low carbon or resilient environments, they need to be high performing as well. So I think you have, many of you have probably seen this a lot. Hold on as I get to my next page. There we go. This particular slide, embodied versus operational carbon from Architecture 2030. And, but I just wanted to highlight a couple things that we've really recognized is in the very near term, while traditionally we've thought that over the life of a building, about 20% of the carbon emissions are associated with materials and 80% are associated with operations. In the very near term, over the next 30 years, that switches up and you actually have the embodied carbon and the operational carbon being almost equal. Even more so now, as we are really, accelerating the electrification of our buildings and as we are accelerating the kind of the decarbonization of energy, that 51% on operational carbon is going to go down. And what you are going to be seeing is that the carbon impacts, the majority of the carbon impacts that are associated with our projects are going to be the stuff we're putting in, with either using to build it or to, the furniture that's in there. All the things that we're kitting out our spaces with is going to be the resulting carbon impact. So we really need to get a handle on it and start to reduce that. Embodied carbon, what is it? I think you probably know this, but just to verify, it really is about all the stuff that's used to make the buildings from the early point, the materials of extraction, whether it's, excavating the stone out of the side of the mountain, or even, pulling the oil out of the wellhead for the plastics or the fibers that you're going to be using in your furniture, to the actual manufacturing of the materials, to the transportation of those materials to the site, and then of course the building construction. So what are some strategies that we can actually use to help reduce the embodied carbon footprint? Well, first of all, there's the whole idea of right sizing, designed for a proper space. We don't build, don't kit out more than you need. And I think this is one of those things that's really interesting, where you had the whole idea of open plan that actually was using less stuff. There were less walls, but now because of COVID and because of, you know, safety and health, we might need to be building more private offices. We don't know, but you know, really important to think about the idea of right sizing. And then what we're really going to be focusing in is the whole idea of selecting low and zero impact materials. Of course, another big area from an embodied carbon perspective is reusing buildings instead of engaging new construction. The whole move in terms of adaptive reuse is huge in terms of helping to reduce the embodied carbon footprint of space. And then, of course, finally is offsetting through net positive production and increasing carbon sequestration. But those are kind of, you know, overarching kind of high level strategies that we're looking at. So what are the you know, kind of the impacts from a designer perspective? A designer really has the ability to impact the carbon footprint of buildings right now. We look at, you know, this is the use stage is the life cycle of a building, and you look at everything that's going into what's being built right now in this practical, or even, you know, before zero. That's all the stuff that's going into the building, and that is really where you know, the embodied carbon impacts are coming from, and where a designer has huge say on you know, on that. And so really we're going to be focusing on that today. And then, of course, during the life of the building or the life of the project, you have periodic replacement and maintenance, particularly in like commercial interiors, where the average turnaround or the average refresh is anywhere from 5 to 10 years. You know, so this could actually be a whole lot more, where you're going in and you're putting in new paint, you're putting in new wallboard, you're changing out the ceilings, you're changing out the flooring, changing out use, and all that adds, you know, embodied carbon footprint to a project. And of course, then at the end of life, if you don't have materials that can be recycled or reused or, you know, disassembled to go back into a circular economy, and they end up being landfilled, of course, you're taking another hit from an embodied carbon perspective. So there are many different places that embodied carbon pops up over the life of a project, but really it's right now at the beginning, whether this is a new tenant fit out in an existing building, or, you know, kind of, you know, a full new install of all your, you know, all the materials that are going into a new hotel. That's happening right up here early on, and that's where you really need to be focusing. But before we go on to a little more detail on the designer side, I do want to highlight that this is not something that's going to be solved by the design team alone. This really is a partnership with the contractors, with the manufacturers, and of course the owners and the users. But from a designer perspective, you know, we talked really, you can, you know, be thinking about how do we reposition, how do we reuse the existing buildings, how do we reuse existing parts and pieces if we're going into an existing space and it already has ceiling tile in it, can we reuse that existing ceiling tile? Optimized choices, do we really need it? How much do we need? Once decided that it's needed, what really is the carbon footprint, and do we have options that have lower carbon footprints that we need to be paying attention to? And then also, you know, specifying for carbon reduction, working with the manufacturers to reduce. From a contractor perspective, and this is something we've really learned, it's very important that the contractors actually are in on this and in alignment with really seeking out lower carbon alternatives to products. Oftentimes they have dedicated supply chains that may or may not, you know, actually be the ones that have the lower carbon materials. And so we really want them to be working with their supply chains to leverage that. Clearly, they need to be able to not be afraid. They need to be speaking up and saying, you know what, we may not know that much about embodied carbon, or maybe we know a lot, and we're in the position of being able to educate the design firms and the owners. Involved in estimating the carbon footprint as well, because you know the quantity of materials, and estimating carbon footprint is all tied to the quantities, and the contractors really have the best handle on the actual quantities. Smart procurement, we talked about, it's, you know, really suggesting options that save emissions, what you're doing from your supply chain perspective, engaging in policy discussions, and then of course informing, educating, and pushing. And then the manufacturers. You know, first and foremost, going out there and doing life cycle analysis on your product, on your supply chain, and really figuring out what the impact is of your product, identifying where you can be making improvements. Like I said, targeting highest carbon impacts for footprint reductions. What are you going to be doing over time? Because this is not just a one-time deal. It's not going and just saying, okay, what's my footprint? Now saying, what are we going to do to reduce? The idea of being able to source renewable energy for your manufacturing processes, whether it's, the energy that you're using for your ovens to cure, whether it's a carpet or a piece of glass, and, how can you source renewable energy? Commitment to recycle carbon intensive materials, that you want to, things that are polymer based, for example, or that, require a lot of heat in their manufacture. How do we make sure that we really are designing to recycle those and be able to take advantage over time of that energy consumption during the production? Aluminum and steel are great examples of, again, carbon intensive materials, but once they can be recycled, they significantly reduce their carbon footprint. And working, of course, also the whole idea with new product development teams. So there's things for everybody to be doing, in this effort to reduce the footprint, reduce our embodied carbon footprint. And important too, this little note down here, but these are all interchangeable. Different companies, different folks are going to be involved in different parts of this, but the owners and users clearly also, apply all these ideas and thoughts and activities apply equally to the owners as well as to the users. So honing in specifically on kind of from a designer perspective, interior designer perspective, on things that we can be looking at in our projects. First and foremost, the thing that you need to be thinking about is putting yourself in a mindset of learning every day. And it's going to be exploring new materials. It's going to be doing a deeper dive on something. But you look at saying, understanding all the different categories, what you're typically specifying, establishing baselines, so you understand kind of what's the rule of thumb for the footprint of whether it's a carpet or a ceiling tile or a task chair. Looking for different opportunities, reaching out to all the different manufacturers, having the conversations with their reps, saying, what are you doing about, understanding your carbon footprint? Where are you, what are you working on? Are you developing new products that might have a lower footprint because you're doing some material changes? And then, of course, you want to design with them and you want to specify with them. You then want to make sure they get procured and built into the process, and it's really important, this follow-up throughout the whole procurement and through the construction phase, that your products actually get in, and then tracking and verifying, saying, yep, that was the product, we specified that product, it actually got into the project, and we can then really understand the footprint and see how it's performing, and helping to close the loop. There is no shortage of carbon footprint information. I mean, it's what's happened in the industry over the last 5 years. It's just blossomed. It's gone, it's huge. What we know now compared to what we knew 5 years ago is just mind-boggling. And one site I want to encourage you to check out, it's buildingtransparency.org. It's now the owner of this tool called EC3. It's the Embodied Carbon Construction Calculator, sorry, EC3. And you can go in there now and you can search a whole bunch of different categories and find, what the carbon footprint is of a bunch of materials. And every day they're adding new materials and new product categories. And you can, from there, download what are called environmental product declarations. These are, in essence, the nutrition label for products that, among a lot of other pieces of information that are included in these EPDs, is the carbon footprint of the product. And so you can, really kind of get an understanding of that footprint through this. But the EC3 tool does a really great job of simplifying it for you, being able to compare products to one another, and so you start to get your understanding of the market space. And then you can start to, really be putting it all together. This is a study that we recently completed for a big project they're working on in New York. And now, of course, we're using it over and over and over again. But what really starts to get interesting, like we mentioned, the different categories, for example, paints and coatings and interior installation. And you see here, what this shows is the carbon footprint normalized to all the products. That you have. This is kilograms of carbon dioxide equivalent, CO2e, normalized to 1 meter squared of surface area that's covered. And it really is astounding as you start to deal through this, and you start to see, wait a minute, why in the world is there a 30x differential in the footprint of paints, you know, in this category on a carbon footprint perspective. Again, we are holding performance criteria the same. So they all meet the same performance criteria. That's not being sacrificed here, but because of how things are manufactured, there really is this huge footprint. The same with interior insulation. The same with, you know, the same with a lot of your ceiling finishes. Again, very large footprint differential, non-carpet flooring, and of course, carpet flooring. That's where we actually first started looking into this. And it's like, oh my goodness gracious, how is it that I can have, you know, a carpet that performs the same and one that gets delivered and installed at 4 kilograms of CO2 per square meter and the other at 30? Come on. And so we really have to be, you know, one, it's of course eye-opening. Some manufacturers, the ones that are in the red end of the zone here, are not so happy about the fact where they land, but we're working with them and identifying it and talking to them about it. If you have that conversation with the manufacturer, say, you know, we love your product, we love the design, your, you know, supply chains, you know, you're so reliable, it's great, but we have a problem when we're taking, you know, a 10, 15, 20% or 20 times hit on the carbon footprint. So what are you doing about it? And that's what's really important, to have that conversation and you know, to recognize that this is a partnership. We want to improve products because eventually we want everybody to be green, right? Everybody down at the low end of the carbon footprint world. When you start to then put this together, this was a project we did. It was an interiors project, not that large. We did a baseline analysis and say, if we didn't specify particular low carbon materials, just kind of what's the industry average for this product category, we had a project that, you know, basically has a footprint of about 10 pounds of CO2e per square foot. And that's, you know, a typical number you can use when you're talking about interiors. You know, probably anywhere from, you know, 7 to maybe 15 is pounds of CO2 per square foot, kind of typical average. But we were able to, just through, you know, smart specification of product, no increase in project cost, was not allowed. There was a little bit trade-off, a little bit more design, you know, effort went into design and tracking down materials. But we basically were able to achieve a 43% reduction, no increase in project cost, no change to project schedule, but a significant reduction in its carbon footprint. And you can see, you know, where we made big differences. Carpet was a big one for us. Glass was another big one for us. Paint, I mean, again, I had paint, what's that footprint coming from? But it's a polymer, it's a plastic. And so these are things that you can do easily yourself right now. The data is there, and we can just start making it happen. But a final word, and that is, if you don't spec it, you probably won't get it. And either if you're speccing it through a project manual or you have it on a plan spec, you have to spec it. The first and easy thing to do is ask for the environmental product declaration to make sure the manufacturer knows what their footprint is. Then you can do things like, if you want to say, you know what, we're actually going to give preference to products that have a lower footprint, and we're you know, giving ourselves that freedom. Or where we're even starting to get in a situation now where we know enough about a particular category that we can say your global warming potential can't exceed X. But the most important thing, again, is if you don't spec it, you're not going to get it. You probably won't get it. And you really, you know, do plan on starting to have that conversation, that language into your specifications. And with that, I'm going to pass it on to Jen.
Great, thanks, Kirsten. I will share my screen. Okay, so that was a great setup actually for my content. So I will refer back to some of the slides as I'm going through. So I am Chen. I'm with Element Architects in Seattle, and I will be talking about embodied carbon and tenant improvement cycles. So this is an overview of the carbon that goes into a building. And there is the initial embodied carbon consisting of all the layers of the building on that first column on the left. And then plus the operational carbon over time as the occupants begin to use the building. So at the first point of occupancy, this is where Kirsten was saying that the embodied carbon is actually more than the operational carbon. It is all in the building materials at the initial point of the buildings. So one can imagine that the embodied carbon has been spent, so the quantity stays consistent through time while operational carbon begins to accumulate. However, we know that TI renovations often happen multiple times throughout a building's lifespan. For workplace, it is often at a rate of about 10 to 15 years or less, and it's much shorter, often for retail and hospitality. So what this means is that the embodied carbon of a building actually continues to increase along with the operational carbon. In Washington State, a bill was passed in 2019 that committed the state's electricity supply to be carbon-free by 2045. In this scenario, the embodied carbon of a building continues to increase while the operational carbon flatlines after 2045. So it actually surpasses, or the embodied carbon of the building actually surpasses the operational carbon throughout the building's lifespan. So this got me thinking, what fraction are TI renovations when we think about it in terms of the overall lifespan of a building? So to understand how cyclical renovations contribute to a building's embodied carbon, we decided to look at our own office's renovation history. We have a great in-firm archivist who was able to get us old drawings and photographs so we can see what went into our building renovations. So you can see here there's been a few major renovations, and in 2000 the building was also reglazed. LMN moved into the building in 1984, and this is the Norton building in Seattle. So we took all of the drawings and did this graph of the scope of demolition and renovation, and we did takeoffs of all the finishes that we know of, and then we plugged these information into the Carbon Leadership Forum Tenant Improvement LCA calculator. What we did is we customized a calculator to be able to do a summation of all of the renovations in total. And here is the result. What we found is that the cumulative TI embodied carbon over the 36 years LMN has been in the Norton building, it is actually quite significant compared to the structure of the building. When we did the study, this was all prorated to just the 2 levels that we occupied. So we made sure that we did that comparison correct, and the building structure and envelope was kind of compared against the CLF baseline to make sure this is typical for a workplace building. And keep in mind, this is excluding mechanical systems, electrical and lighting portion of the remodels. So this is sort of the bare minimum in terms of finishes and material of the cumulative embodied carbon. And the building itself is built in 1959, so even though we only have data starting from after we moved in, we can assume that if we were renovating at a rate of 9 years or every 9 years, we probably would have had another renovation 9 years prior to this. So this, if we add that on to our cumulative embodied carbon, the overall value is actually higher than structure. And if we can achieve the 30% reduction in concrete mixes that we can with current day technology back when the Norton building was built, the cumulative embodied carbon is actually higher than structure and envelope combined. So as you can see, throughout a building's lifetime, the TI embodied carbon actually adds up fairly quickly. So what can we do to lower the embodied carbon of cyclical TIs? Kirsten gave a lot of good examples of kind of really easy ways that you can do now to lower embodied carbon. And I think in a way to think about it is through circular economy. This is a great concept to keep in mind while designing. So in a linear economy, the embodied carbon spent at every stage of a product's or a material's life cycle is wasted when the material goes to landfill. But if we can recapture and reuse some of that material, then we can eliminate some of the wasted carbon. And in a true circular economy, the carbon is not wasted and carbon output is minimized. And just some materials and products that I came across while doing this research. This is a case study that the Davies Office Furniture and Remanufacturing did. So what they do is they take existing furniture without having to process it from raw material again. And they cut it down to match, say, another piece of furniture, and then they repaint the furniture. And what they found is that compared to a traditional sort of office system, their remanufactured system is actually only 17% of the CO2 equivalent. And to be able to maximize a material's reusability, we can think about designing for deconstruction. So this is the steel case think chair, which is designed for easy disassembly. It is said that you can disassemble this chair in 5 minutes with simple hand tools. So what this does is that if a piece of the furniture or this chair becomes damaged, you can replace just that piece rather than having to throw the whole chair away. And we can think about that in terms of other building materials as well. If we can be thinking about designing for deconstruction or disassembly, we can more readily think about how to creatively use materials. For example, using less nails or glue, but instead of using screws or universal connectors can help can help this deconstruction without damaging a material too much. And even when that becomes the case, like this wall that you see here, this was an assembly that was difficult to deconstruct. So Dave Bennig, who owns Reuse Consulting in Seattle, saw an opportunity to reuse the whole assembly. So if we can think about that, he believes that we have we can be able to recapture designed for a deconstruction building and recapture materials by up to 90 to 100%. So that's quite a bit of embodied carbon savings. So finally, I wanted to simulate how much impact some materials and design decisions might have on the overall TI embodied carbon. So the bar in the middle here shows the baseline in terms of the LMN 2015 office renovation, and that is the current version that we are in right now. It has minimal palette, and it is open office, so there's very little walls. It's an open ceiling, so there's no acoustic panel. But this is a case, moving to the left, a case of minimizing material palette. If you don't need it, that's a way to save embodied carbon. So on the left, this is a simulation for what if we had acoustic panel rather than open ceiling. And you can see that there's a noticeable increase in the overall embodied carbon of that renovation. And I was glad to see Kirsten's slide of that 43% reduction, because this is a simulation, and I was like, really, we can save almost half right away? And it is possible. Just really quick, touching on the baseline, because it is an open office, there's minimal finishes. Furniture, such as the Herman Miller air-on chair in the workstation actually is quite significant. But if we think about, you know, remanufactured furniture or picking that carpet tile that went from, you know, 30 to 4 GWP output and using EcoSmart JIP to lower the embodied carbon of these materials, it quickly goes down to almost half of what our baseline was. So, you know, I encourage all of you to really think about asking for and specifying materials that have low embodied carbon, and to push for that from the manufacturers as well. And the missing piece is MEP, so I'll pass that on to Kelsey.
Great, thanks, Jen. That's perfect, because that's exactly what I'll cover, and you set me up for this MEP study that I'll go into that kind of goes into depth of the missing piece. So one of the themes we've been hearing throughout today's series is you can't manage what you don't measure. So starting to get a baseline understanding of LCA analysis of buildings and projects for our firm, we quickly see that structure, envelope, and interiors are the most common elements measured. So when we started measuring that for this interior renovation project, we also wanted to find out what the embodied carbon impact of MEP systems were for this project. So this is an office building interior renovation in Baton Rouge, Louisiana. EskewDumezRipple is based out of New Orleans, and I partnered on this project with Bernhard, a local MEP firm, to help figure out the method and making sure that I was including the MEP system scope that was necessary, and then verifying my numbers with the installed material. So the project is 12,000 square meters, 8 stories, and the interior renovation came about as a need for mechanical system upgrades. The project was built in the 1980s, and there were issues with occupant comfort. So that really drove the overall renovation of this project. So like I said, we wanted to do a quick baseline LCA of the office renovation and compare that to new buildings. So similarly, looking at the Carbon Leadership Forum benchmarking averages puts us for a typical new concrete and steel building at about 420 kilograms of CO2 per meter squared. And then we took the as-built condition and put this through Tally and checked to see if our baseline building kind of aligned within the bell curve there, which it does at 320. And then just to drive home the point of kind of scale of what we're saving through renovation, just wanted to reiterate that we kept the building in envelope, and along with the MEP upgrades that we'll get into, we didn't change the envelope from the 1980s. All we did was change the mechanical system. So this is a huge potential savings just in not rebuilding a new structure. But of course, we wanted to study our impact of the interior renovation, which was pretty minimal. Similarly, we kind of reduced a lot of the interior partitions to make for a better interior space. And that saves us on material impacts. But the renovation itself, through walls and carpet tiles and finishes, puts us at about 50 kilograms of CO2 per meter squared. So really quickly, just comparing the scale of renovation impact versus building new, you know, we see something, a really significant savings, about 1/8 of the carbon, you know, emitted in doing a renovation instead of building new. It also comes with some aesthetic upgrades. This building has not seen that typical kind of 5 to 10 year renovation cycle and had all its original finishes from the 1980s. And because we had the MEP system upgrades, we got to do some interior upgrades. So there were spaces where we opened up the floor and created double height spaces, created stairways for occupant health and for daylight, just providing more circulation opportunities. So a significant aesthetic and architectural opportunity, as well as a carbon savings. And the carbon savings obviously come from not building new, but really what we'll see here is that the operational impacts were significant in mechanical system upgrades. Those upgrades were somewhat minimal. We were able to save the cooling tower that already existed and maintain that system. And then all we did was change the distribution system from a VAV to a VRF. And then there were lighting upgrades, taking our 1980s lighting to LED fixtures. And all of these combined, again, not even touching the building envelope or the glazing, brought our building site EUI from 93 to 27. So we cut it in about a third. So that's a great, pat on the back, but we wanted to look at what the embodied carbon of that system looked like as well. But before I go there, I want to just touch on what those system upgrades did for occupant health. Before the project, we measured the CO2 levels in the building at an average of about 1,000 parts per million. And with the new dedicated outdoor air system, it's designed to peak at 650 parts per million. So we get a significant better air quality and better occupant health through these upgrades. But we also want to talk about planet health. So that's measuring CO2 in the atmosphere. So we took the Revit model of the mechanical upgrades, the ductwork, the electrical, the plumbing, and the mechanical equipment, ran that through a Dynamo script, and came to the renovation coming in at about 35 kilograms of carbon per meter squared, which is about 40% of the overall interior carbon impacts. But again, overall, once we even include MEP, we're doing so much better than building new. And then before I move on to some of the details of the MEP study, I want to talk about that at scale. After I talk about some of the details of the MEP study, I want to talk about that at scale. So the embodied carbon, great, we got a savings there by not building new. Like I said, we brought the operational carbon, well, the operational energy use, the EUI, down from 93 kBTUs per square foot per year, which translates to about 140 kilograms of CO2 per meter squared on our grid in Louisiana. So this is what the building looked like from an embodied carbon and operational carbon standpoint from when it was built in 1984 to 2030. But that's not what we did. We did this renovation. And so here we see where that operational impact is pretty significant from a building that hasn't been updated for energy codes. So diving into that embodied versus operational carbon, the embodied carbon of the renovation, again, that 85 kilograms of CO2, and we quickly see that the operational savings end up in a 1-year carbon payback, right, where these lines cross from the existing condition to the new projected energy use. So by 2030, that's a pretty significant savings of about 950 kilograms of CO2 per year, or sorry, total by 2030 per square meter. So this is where I want to talk about the importance of renovation and scale globally and nationally. So looking at the CBEX data set, there's about 15,000 buildings still standing from the 1980s today. And each of those are about 1,500 square meters. So if we were to take all of those buildings across the country and do the same pretty simple mechanical system upgrade to basically build these buildings, bring these buildings up to today's code, we would be saving over 2 million tons of CO2 in a year. Which is the equivalent of taking almost 500,000 cars off the road per year. So that covers kind of this, again, a really good success story of saving embodied carbon by doing a renovation and saving operational carbon as well. But like I said, we replaced a VAV system with our VRF. So we also started asking questions about what the impact of refrigerants are and what that potential could be. So we've got our embodied carbon upfront costs, basically, of the MEP system here. And here we see the operational carbon. And we see pretty quickly that even by 2030, operational on a standard grid, not on a green electrified grid, is going to overtake the embodied carbon impacts. But then once we factor in leakage rates, we also find out that refrigerant leaks are pretty significant, and we need to keep an eye on this. This is using a warranty rate average, and we're working to measure this on local buildings and kind of check if this is the exact radar of fear we should be having of about a 5% leakage rate, which is about 10% of the operational carbon per year. And this is using a GWP 100 year number. And the other important thing to know about refrigerants is the 20-year number is often thought of as more accurate because of how refrigerants release and last in the atmosphere. So when we look at the GWP of the refrigerant we used, those impacts with refrigerant leaks almost double. So we see a more significant impact there, and that gives us something both to measure if our systems are leaking, and then how to manage it, how we can manage refrigerant leaks and be working with our MEP contractors and maintenance teams on that, and be designing in maintenance and measurement of refrigerant leaks so that we can get this problem under control. And that kind of sums up the overall takeaways of this. And I want to leave it on a high note, pointing out that the embodied carbon of renovations is still a really smart thing we can do with our existing building stock as designers. And it's super small compared to the operational impacts. And there's a huge scale opportunity by looking at our existing building stock for these renovations. Again, I do want to point out that today's refrigerants could have a pretty significant impact, but not enough to outweigh the savings that we got from that 93 EUI, or about 150 kilograms of CO2 down to about 50. We're still at a third, even including the leaks, or the potential leaks. And then for those of us who are paying attention to refrigerants, we know that there are plenty being released on the market today that have a GWP closer to 1. So that's a lot of opportunity, again, to reinforce the need for MEP systems. And then our target can go to, this is kind of the next step of work, the target can go to optimizing those MEP systems. So that's kind of ongoing work I have, there's a task force kind of working on continuing to measure embodied carbon, making sure that we've got consistent case studies, including this, because as we said, LCAs don't have MEP accounted for often. So we need to get kind of a benchmark of this. And I started some of that work, like this case study I shared, but I've got a full booklet of 8 case studies, some including MEP, and going through that embodied and operational carbon kind of reduction and life cycle analysis. But it's ongoing work. So if you're curious about the MEP system aspect or life cycle analysis of renovations or new construction, feel free to reach out and I'd be happy to share it.
All right, thank you all. So we are unfortunately right at the end of our allotted time for the session. So I'm just going to give a really quick wrap up, and then I will leave this session on to answer a few remaining Q&As. But to our attendees, thank you so much for joining the Carbon Positive Reset. It was wonderful to have you all today, and I hope you found it educational and inspiring. We will be doing one more 30-minute tool demo right after the session, and you can find all that information on the agenda. And if you're interested, we're also going to be having a Carbon Positive Reset, similar format for Europe, Middle East, Africa on the 17th, and then Asia, Pacific, Oceania on the 22nd. I encourage you to tune in, or if you have colleagues internationally, recommend it to them as well. So with that, I'm going to officially close this session, but leave it open for Q&A. Thank you. All right. So I saw we had one question come in that already got answered regarding the use of the EC3 tool, Kirsten, in the project. Do you want to maybe expand on that for everyone else? And then I know, Kelsey, you had a question as well.
The kind of our understanding of the range of carbon footprints of projects has been kind of been underway for a couple of years. So when we were starting with some of the original work that we did, EC3 didn't have any interiors projects. So the question was, you know, did we use the EC3 tool in you know, kind of getting the information to help craft our understanding of the footprint of the different products? And yes, we did use the EC3 tool, and we are using it more and more and more, but our work has also been informed by information that we've gotten from One-Click LCA, as well as, you know, a lot of it just came directly from manufacturers and getting their environmental product declarations and reading through them to understand the footprint. In part because EC3 actually originally started focusing on the major construction materials on kind of concrete steel, and just over the last year have started to add in more interior materials. So it's becoming more and, you know, much more robust platform of data. But we used all those sources to inform our understanding.
Great, thank you. And then Kelsey, you had a question for the team about cost premiums and specifications, right?
Yeah, I was curious, Kirsten, about once you worked EPDs into your spec, if you've started to see a cost premium, or if that's just budgeted in as this is how we offer our projects, and people know that that's what to expect, or is there a cost premium when you start to source a product with an EPD?
So there's a couple things. One is that there is, you know, a definitely level of effort required to update the specification to reflect those criteria, right? And you're kind of chunking it off. And so you certainly, we have projects that have been able to carry the load in you know, some of the most expensive, I would say, designs, you know, updated specifications has been associated with more concrete specifications for projects. And that's, you know, but we work with our structural engineer. Where the challenge has been is that we oftentimes are moving away from prescriptive standards or prescriptive specs that specify here's your mix design to say here's the performance criteria, and then letting the local supplier, you know, work their magic to come up with that design mix that actually meets the criteria but also delivers lowest carbon footprint. But once we've done that, we have that available to us now, so it starts to inform and make it easier and lower cost for all the other projects, right? So that's the thing, is how we leverage and how you share that knowledge. We are looking at, on the building transparency site, through our materials can section, to actually start to put out, like for example, for public projects where specs are open source, to make those available so that they're available to other designers to be able to just, you know, hey, you can see, here's an example of a specification that already has these incorporated in there, so you don't have to, you know, in hopes that it will speed up implementation because it's reduced the design cost. Then you have then there's you know, from the bidding perspective, and is there a construction cost increase? And most of the time we are including, you know, we're updating specifications for product categories that already have this information, that we know it is there. And so there should not be a cost premium because it's already, you know, basically it's been vetted before it even goes out to bid. The big challenge that we have is where particularly the contractors want to do substitution requests, right? And saying, you know, they have this great product that's a whole lot cheaper. We think it meets all the performance criteria, but we haven't done the LCA, you know, we haven't done our EPD yet. And that's why it's so important to have that information and that requirement in the specification, because if you don't have it, you're not going to be able to push back on the contractor and their supply chain to say, fine that you want to propose a substitution, but it needs to meet all the performance criteria, including its, you know, global warming potential. So.
Great, thank you.
But again, it's really, yeah, it's really important to have the conversations and to keep the contractor and their supply chain aware of what's going on. You just don't want to throw this out at them at the last minute and they're going to go, ah.
Yes.
Great.
Great, thank you so much. I'm not seeing any more questions in the Q&A feature. So unless there's last minute questions there, we can probably call it a wrap on the Carbon Positive Reset. And again, thank you, Kirsten, Kelsey, Jen, for your insight and your expertise on this topic. And thank you to all our attendees for joining.
Thanks for having us.
Thanks,
Thank you, everyone.
Bye.